Hello everyone, I'm Said and welcome back to the channel. Today we're gonna look at a classic problem in calculus involving Riemann sums. Specifically, we'll see what happens when we try to calculate the upper and lower sums for a function that is discontinuous everywhere. First, let's look at our general rule. Suppose we have a function defined on an interval a to b as follows: f of x equals L1 if x is rational and L2 if x is irrational, and also L1 is less than L2. So we want to find un of f minus ln of f. Un of f means the upper sum and ln of f is the lower sum. Because the rational numbers and irrational numbers are dense in any interval, in every subinterval, the maximum value will always be L2 and the minimum value will always be L1. This gives us a simple result for our upper and lower sum. This means the upper sum means un of f is simply the length of the interval multiplied by the maximum value means un of f equals b minus a times L2, and lower sum means ln of f equals the length of the interval times the minimum value. So the difference between them equals b minus a times L2 minus L1. Now let's apply this to a specific problem. Number 1. F of x is 2 if x is rational and negative 2 if x is irrational in the interval negative 1 to 2. Let's solve this step by step. Step 1. Find the length of the interval means 2 minus negative 1 equals 3. Step 2. Identify L1 and L2. In our function, the value for rationals is 2 and for irrationals is negative 2. So our minimum value means L1 is negative 2 and our maximum value means L2 is 2. So un of f equals length means 3 times maximum value means 2 equals 6, and ln of f equals length means 3 times minimum value means negative 2 equals negative 6. And next step, find the final difference is 6 minus negative 6 is 12. Or f of x equals 2 if x is rational and negative 3 is irrational. Find un of f minus ln of f on the interval 0 to 1 for n equals 10. First, notice that in every subinterval of 0 to 1 there are always rational and irrational numbers. So in each subinterval the greatest value of f of x is 2 and the smallest value of f is negative 3, and the interval length is 1 minus 0 is 1. So the upper sum means un of f equals 1 times 2 equals 2, and ln of f equals 1 times negative 3 is negative 3. So un of f minus ln of f equals 2 minus negative 3 is 5. You might be wondering, what about n equals 10? Does it change anything? The answer is no. Because rational and irrational numbers are dense in the real numbers. It doesn't matter how small you make your subintervals, even if you increase n to million. In every single subinterval, no matter how small, you will always find both rational numbers where the function is 2 and irrational numbers where the function is negative 3. So the maximum on any subinterval is always 2 and the minimum on any subinterval is -3. Or we can say, since the maximum and minimum values are constant across the entire interval 0 to 1, the partition size n cancels out when you calculate the sums. So whether n equals 10 or 100 or 10,000, the result un of f minus ln of f will always 5. It's very, very important. Let f be the function defined on the interval 0 to 3 by f of x equals x if x is rational numbers and 2 if x is irrational numbers. Consider the partition of 0 to 3 into 3 equal subintervals. So what is the upper sum means u3 of f on 0 to 3. Step 1. Set up the subintervals. The interval is 0 to 3 and we have n equals 3. So delta x equals total length, means 3 minus 1 is 3, over number of intervals, means 3. So we have 1. So our subintervals are 0 to 1, 1 to 2, and 2 to 3. Step 2. Find the maximum value for each interval. First, 0 to 1. The maximum value is 2. But why? When we conclude the upper sum, we need to find the maximum's possible value in each subinterval. So you should ask yourself, in this specific area, which layer is higher? We have y equals x and y equals 2, right? And as you know, x is between 0 to 1, so y is between 0 to 1 and y is 2, so maximum value is 2, right? F is 2. And for interval 1 to 2, y equals x and y equals 2, right? So x is between 1 and 2. So y is between 1 and 2. So the maximum value of y equals 2. So in this interval, f equals 2. And for the interval 2 and 3, y equals x and y equals 2. So x is between 2 and 3. So y is between 2 and 3 and y equals 2. So the maximum value of y is 3. So f is 3, right? So u3 of f equals the sum of maximum value of f times delta x. So we have, in the first subinterval, f is 2 and delta x is 1. So we have 2 plus, in the second subinterval, f equals 2, and in the third subinterval, f is 3 times delta x. So u3 of f equals 7. F of x equals 1 over x on the interval 1 to 2 when the partition is 1, 4 over 3, 5 over 3, and 2. So find the upper sum. First write the subintervals. Means 1 to 4 over 3, 4 over 3 to 5 over 3, 5 over 3 to 2. And as you know, f of x equals 1 over x is decreasing on 1 to 2. That means on each subinterval, the maximum value occurs at the left endpoint. So the maximum values are f of 1, f of 4 over 3, and f of 5 over 3. And each subinterval has width 4 over 3 minus 1 is 1 over 3. 5 over 3 minus 4 over 3 is 1 over 3. And 2 minus 5 over 3 is 1 over 3. Right? So delta x equals 1 over 3. So u equals f of 1 plus f of 4 over 3 plus f of 5 over 3 times 1 over 3. So f of x equals 1 over x, right? So f of 1 is 1, f of 4 over 3 is 3 over 4, and f of 5 over 3 is 3 over 5 times 1 over 3. So final answer is 47 over 60.